So this is the lightning talk. It's in a half-hour slot, but it'll probably take about 10 minutes. Then I've got kind of a live demo set up for people to have a poke about with if you want. So I'm Jon Seager. I'm a VP of Engineering at Canonical. I look after kind of the development of Juju and our Charmed ecosystem, and I have a kind of bit of a sidebar interest in observability and more recently in continuous profiling. So I'm going to talk about some experimentation I've been doing there. And my clicker doesn't work. Oh, there we go. Oh, wow. Okay, so firstly, what is profiling? So profiling is all about dynamically measuring applications at runtime. It's about trying to get deeper insights into the amount of memory that an application is using. It's about measuring the CPU usage, perhaps the number of threads or Go routines. And that's all done while the application is running, generally kind of in production as it's going along, but more frequently kind of in development. In general, this has always been done in the past as kind of a point-in-time basis, like your application does something weird, so you go and profile it to try and understand what's going on. This has some kind of interesting negative side effects. So one is you don't really understand what the effect of the profiler is on the application. Like if it's already under load and all of a sudden you're hitting it with a profiler, is there any kind of overhead associated there? But also, you can kind of miss the boat, right? Like if it's been misbehaving and at the point where you take the profile, the behavior you're trying to capture is not exhibited, like you don't have anything to go on, right? So it's kind of a timing problem. So continuous profiling is trying to combat that by introducing time as a dimension to your profiles. And the idea here is rather than profiling only when something goes wrong or at specific points in time, you profile continuously, perhaps every few seconds or every few hundred milliseconds, much like Prometheus would go out and scrape for metrics, you can scrape for profiles. This is also not a particularly new concept, so Google actually documented a practice like this back in 2010 in a paper called Google-wide profiling, and it was around that time that they started investing, I believe, in the pprof format, which has become kind of an industry standard for profiles themselves. Like the actual profile data you capture will often be in this format, and so, for example, the Go language has a pprof package, which you can kind of trivially import into your application and allow it to be profiled without a huge amount of effort. So the idea here fundamentally is keep profiling your application as often as possible in as low overhead manner as possible, store all those profiles somewhere, and then be able to query them and understand kind of over time how your application is behaving. And of course, if you have this kind of nicely integrated with your other time series data, like your metrics and your logs and various other things, perhaps your traces, you can then start to correlate very, very high memory usage that you're seeing perhaps in a profile with the log lines from the same point in time and perhaps a couple of spans from a trace, and so you kind of get a bit of a better chance of debugging what's going on. So there's a whole bunch of companies that have kind of turned up to the party to do this. gProfiler was actually acquired by Intel. Datadog have got a profiler that you can install. Splunk, Instana, Elastic acquired Optimize, I believe, and there's just last week, Grafana also announced Flare, which is another profiling product. And there's two kind of, to me at least, two standout open source offerings. One is Pyroscope, that's been around for a little while, and the other is Parca from a company called Polar Signals. I was kind of captured by Parca a little bit. I was interested, not least because I think their tech is interesting, but also because it seems like quite a sort of open approach to profiling. A lot of the other tools are quite focused on perhaps a particular language or a particular runtime. And Parca takes a lot of it, I guess, influence or inspiration from Prometheus. So the way that it's configured to scrape things, for example, is very similar to Prometheus. And it has its entirely bespoke backend for storing profile data and querying profile data. And I have quite a lot of confidence in the folks that are leading the project. It seems to have been set up in quite a sustainable way. So their model for kind of accepting contributions and maintainers from outside of the core maintenance team seems to me like a very sustainable and kind of interesting project. They're friendly. They've got a very friendly community. It's growing. They have a kind of quite an active Discord server, and they're pretty responsive to kind of pull requests and things. So I basically dived in and had a bit of a play with it over the last couple of months. So alongside their server component, which is the thing which kind of allows you to store and display profiles over time, and also kind of scrape for profiles, reach out to applications and ask them for profiles, they also provide an eBPF-based agent which you can install on any Linux host. This is another thing that drew me to Parca. I kind of have a bit of a fascination with eBPF, and this means that essentially you can install the agent on any Linux machine and it will go out and kind of automatically profile all of the processes on the machine per C group, per systemd unit. So if you've got a whole bunch of containers running as part of a Kubernetes cluster, on a kubelet, then individual processes and containers can still be profiled at this time for CPU usage only. My understanding is that they are going to develop that further into kind of memory usage and network and I/O, etc. So before I carry on, there's a couple of pretty pictures of what it might look like. So on the left-hand side, you can see a profile of kind of allocated memory over time in I think that's in Juju. I can't quite see, but either way you can see how you can kind of compare 2 points in time, and the graph is kind of coloured. So red is where essentially the application has got worse, and blue is where it's either the same or slightly better. And you can kind of split the view down the bottom, so you can kind of get raw data out of it in table form, or you can display these icicle graphs. I'll show a little bit more of that in the demo in a little while. So I actually wanted to use this not just because I was trying to learn a bit about profiling, but also to kind of show a bit of a test case for how snaps and charms can work together. We've done a bunch of work internally on this across our kind of data platform and our observability team. And so I wrote a couple of snaps and a couple of charms. It was a bit of a dream to kind of snap up. Both components, the server and the client, are just like Go binaries. The agent is a little bit more complicated just because of the broad kind of system access it requires. I started off in strict confinement and have kind of bailed back to classic confinement whilst we figure out the best way to approach that, because it requires such broad access. But the agent is a strictly confined, the server is a strictly confined snap that you can install on any Linux distribution, and kind of the combination of about 3 commands can get you up and running with an agent, a server, all configured and good to go pretty quickly. There is a kind of more detailed write-up of the work that I did at that URL. So there you'll see some kind of screenshots of it working with Zinc and profiling a Juju controller on LXD and on Kubernetes. And there's some kind of step-by-step pieces there if people want to have a play with it. You can also just... clickers on a delay. You can also head over to the Snap Store, so you can install Parca or the Parca agent, and you can deploy from Charm Hub, Parca, or Parca Kates. These are fairly early. The snaps are actually now upstream, so the nice folks at Parca have accepted those, so they're actually publishing snaps to the Edge channel in the Snap Store every time they merge to main, and there's a process in place for them to kind of get the release candidates and stable releases out as well. They were super easy to work with. It's been really fun. And the operators for now, so the charms are being maintained by me kind of as a hobby project, but there's certainly roadmap for our observability team taking that on in the future to add as part of our kind of observability offering. You can find the code mostly on my GitHub, so the operators are up the top there, and the snap code you can find in sort of the upstream Parca dev GitHub org. There's not a lot to it. Like I say, the applications themselves are relatively simple. There's not a huge amount of confinement woes with the server, and the agent is classic confinement. So yeah, that was it. That's kind of the main content for the talk.